Hey, how's it going, engineers? Um, I was looking at the quiz, and it seems like there's some problems that maybe are a little bit tough. So I was going to go through and kind of give you a little heads up. So we didn't get to do this lab because obviously we're not in school. But the idea was you should be able to determine your weight based on how much a wooden beam, a 2x4, two by six here it is, how much it bends. Because the idea is the beam sits flat at a certain height, and then you step on it with your weight, and it's going to kind of bend like this. Okay. And what this shows, what this problem is like, well, what if we did that? So it's a little tough, but it's totally doable. So the goal of this problem is to determine E. So that is the modulus of elasticity. So remember, we have this equation, delta max equals F L to the third over 48 E I. Okay. We're trying to solve for E. Let's adjust this equation to make it so that E is by itself. So what we would do is E is currently being divided, so we would multiply both sides by E. Okay, and that would allow us to get E on the left side of the equation here. And now the delta max is being multiplied by the E, so we're going to divide both sides by the delta max. Okay, so what the result is E is equal to F L to the third over 48 I delta max. Okay, so all I did was rearrange the equation to find the variable that we're looking for. All right, so here's what information we've got. We've got a total span. Let's say the span is 114 inches. I don't know what yours is, but that's what mine is. We also have the base and the height of this, and I remember the moment of inertia is base times height to the third over 12. So let's just start by writing down the variables that we know. Delta max, F equals, L equals, E equals, I equals. Okay. E is what we're looking for. So I'm going to put an E there. L, the length, is 114 inches. The force, in this one, it says the volunteer weighed 137 pounds. So that would be our force. Okay. The I is, we'd have to solve that. We can do that right now. I mean, it's base times height to the third over 12. So the base is 5.5 times 1.5 to the third over 12. So I take out my handy dandy calculator here, and we say 5.5 times 1.5 x to the y 3 to the third divided by 12 gives us 1.546875. And this is more sig figs than we need, but I'm going to leave them all because we haven't gotten to our answer yet. And generally you want to try to keep as many decimal points until you get to the answer, and then you round off. So 1.546875. 1.546875 is our answer there for a high. And then delta max, this is the one where you got to figure it out. Well, if it was originally this high, 3 and 27/32 inches, and when you stepped on it, it bent so that now the bottom is at 2 and 17/32 inches. The difference between those, you see how delta max equals dpl, so preloading before you got on it, minus dal, distance after the applied loading. Okay. So the way we would do this is we would just put in our calculator 3 plus 27/32, because 3 and 27/32 is just like saying 3 plus 27/32. Okay, so that's 3.84375 minus, and I'm going to put this in parentheses, 2 plus 17 30 seconds. Now, there's other ways you can do this. You could just figure out what those decimals are, but I think that this is probably the easiest. So we get 1.3125. So that is our delta max. So we'll go up here and I put 1.3125. I think that's what it was, right? Yeah. All right. Now we're going to plug all these numbers into our equation. Okay, so E equals F, so 137 pounds, times L, 114 inches to the third, so this is all into the third, divided by 48 times E, which is, or excuse me, not E, times I, 1.54687 times delta max 1.3125, right? Because we already looked down here, we already solved for that, what the E was, okay, or we rearranged the equation. Okay, so put this in the calculator, no problem. 137 times 114, and then I'm going to use the little to the power of 3 divided by, now on the bottom I'm going to put all these in parentheses because they all need to be multiplied together, and the way the calculator does it, it's going to do PEMDAS, so it'll just divide by 48 and then it would multiply by these numbers. Instead, we want to divide by all of this, so we say divide by 48 times 1.54687 times 1.3125. Okay, so I put that all in parentheses and I get a big number, 2,082,760.5887. With this, we have 3 sig figs here. We have kind of like 3 here. I would probably say that if you put 2,080,000, that would be a reasonable answer. And the units that we get here, oh, this is interesting. So we have here, we've got inches to the fourth, and here we have inches. Here we've got inches to the third. So the inches to the third and the inches to the fourth will cancel out. So it'll just be inches. Then the inches times inches is inches squared. And we've got pounds. So we have pounds over inches squared, which is just PSI, pounds per square inch. Okay. All right. So I hope that helps. You get the answer to this. And then if you go to the next problem, you just do the same thing, except now you're solving for delta max and you use whatever value you got for E. Okay.